Now, how do we represent vectors? Well, the basic representation of a vector is to use an arrow with an arrowhead. Now, the head of that arrow, we're going to call it the head. Well, it tells us the direction. The arrow, it always tells us the direction. And the tail gives us the magnitude. So when you're representing a vector, you use this arrow there, where you've got a head and a tail. So the head is basically for the direction. Where is the vector going? And the tail is the size of the vector. So if you're going to represent a small vector, you're going to have a shorter tail. A large vector, a larger tail. Okay. Now, for example, we get told that vector A is 25 meters east, vector B is 15 meters west. So vector A is acting 25 meters east, vector B is acting 15 meters west. How would you represent these two? Well, for starters, you can tell that vector A has got a bigger magnitude, is 25 meters, compared to vector B, which is 15 meters. Though they're acting in different directions, but you can still see that the magnitude of A should be bigger than the magnitude of B. Okay? So if that is the length of vector A, then vector B should be shorter. Why? Because vector B is actually smaller than vector A. So you can clearly see that the tail of B is shorter than the tail of A. Okay? That's representing the vectors that, oh, vector A is actually bigger than vector B. Well, what are positive and negative vectors? Well, a vector can be positive or negative depending on the reference system that is used. In other words, in which direction is the vector pointing? If a vector is pointing in the positive direction, the head is going in the positive direction, that is a positive vector. Vector is pointing in the negative direction, that is a negative vector. So let's suppose on our two system axes that we've got here, two-dimension axes that we've got rather, we've got an x-axis and a y-axis. Let's say east is positive on the x. This means that vector A is going to be positive as well, because vector A is pointing in the eastern direction. And vector B, since it's pointing in the negative direction, is going to be negative. So vector A is going to be positive, vector B is going to be negative, because we've made the east positive and the west negative, according to this system of axes. We could as well swap this reference system and say, well, let's make the east negative, let's make the west positive. In this case now, vector A, the 25 meters east, is actually now a negative vector. And vector B, which is going in the west, is now a positive vector. So positive and negative vectors, it's an issue more of the reference system that we use. Which is the negative direction? Is the vector pointing in the negative direction? Is it pointing in the positive direction? Once we can establish that, we can establish which of the vectors is positive and which one is negative. Well, vectors are equal if they have equal magnitude and act in the same direction. That's what it means. When we talk of equal vectors, we are saying they have the same magnitude and they act in the same direction. They do not necessarily have to have the same starting point. They can have different starting points and different ending points, but when we measure the length of the vectors, they must be the same. So the example is vector P and Q in this example. The length of tail of vector P is equal to the tail of vector Q. So these vectors are equal, and they're all pointing in the same downward direction. Or you can say they're pointing in the southern direction. Or you can say they're pointing in the negative y-axis. Okay, so they're equal vectors. Balanced vectors, on the other hand, will have the same magnitude but will act in opposite directions. In other words, they'll have the same tails, but their heads are going in exactly the opposite directions. Okay, that makes these vectors to balance out. So for example, if I had 25 meters east as a vector, and then I also had 25 meters west, these two vectors will balance each other out. Okay. In other words, they will cancel each other out and there will be no resultant. Okay, because think of it this way. Let's say, according to the system that we've got, this east is negative. Okay, so the east is negative. Since the east is negative, it means the east vector is going to be negative 25. So the vector going east will be negative 25, and the vector going west will be positive 25. If we add these two together, we get a result of 0. That's what we mean when you say these vectors cancel each other out. They do not produce a resultant vector. So guys, that's it about the introduction to vectors and scalars. As you work through vectors and scalars, you begin to get used to the ideas of how to represent vectors. When you give the answer to a vector, it must have the magnitude and the direction. When you give the answer to a scalar, you just need the magnitude only. Okay, thanks for watching, guys. In our next video, we're going to start talking about the motion basics, distance and speed. See you guys next time.